Tempo was intended as a research project to bring the predictive capabilities of the human decision making on a chip, to bring the optimization as close as possible to the control, to the embedding of high level control design, knowing that the nowadays platforms will always be better than any human sensing or actuating capacity.
My name is Bartolomeo Stellato. I come from Italy and I'm a PhD student at the University of Oxford. The focus of my research is to solve complex decision-making and optimal control problems at extremely high speeds, usually down to microseconds, on very low-cost computational hardware. These results will be applied to new, challenging academic and industrial applications to control very high-speed dynamic systems such as quadcopters and electric motors.
My name is Goran Banjac, I come from Bosnia and I'm a PhD student at the University of Oxford as part of the Marie Curie project Tempo. I study optimization-based control algorithms that can substantially improve performance and reduce costs of operated technical systems compared to commonly adopted control techniques. Current implementations of such algorithms are computationally very demanding and require high computational power. My research aims to enable applicability of these algorithms to computational platforms with very limited memory and power, such as microprocessors that are usually found in devices such as digital cameras, quadcopters or cars. Although every student in Tempo has a specific research topic, they often overlap and then students often collaborate. As an example, Bartolomeo and I have collaborated on a software project called OSQP.
Tempo allowed me to collaborate with industrial partners such as ABB Switzerland on real-world applications in power electronics. Within Tempo, I managed also to develop non-technical skills such as presentation, career planning and entrepreneurship skills that will be extremely useful in my future career. The most exciting part of my project was spending a few months at Stanford University together with Goran to carry out research and collaborate with exceptional people and leaders in our fields. There at Stanford, we developed a new open source software called OSQP that will allow thousands of people to reliably and efficiently solve optimization problems arising in control, machine learning, and finance. OSQP is available to everyone and is already being used in several universities and companies.
The aim of my future research is to make state-of-the-art optimization tools widespread in industrial applications.
I'm Iris Ballesteros Tolosana. I was born in Spain. 3 years ago, I came to France to become a Tempo Fellow in Renault and Central Superlec. As a Tempo Fellow, I have been working in advanced driving assistance systems, more particularly in the lane centering assistance system, which is in charge of controlling the steering wheel of the vehicle in order to follow the center of the lane. We started working also in trajectory planning and in order to perform lane changes and overtaking in highways.
My name is Mohamed El Araba. I was born in Algeria. My PhD focused mainly on a model predictive controller for time-delayed systems. We have been proposing control methodologies in order to deal with the possible varying delay in the control loop.
When I first applied to join the Marie Curie Tempo project, I was mainly motivated by the international environment where it takes place, because I really think that this helps to extend your expectations and your perspective, both in a personal and in a professional way. There has been a strong collaboration between the university and the company So in my case, for example, Renault and Central Supelec have been collaborating all along the project, which I think it's really important because it really helps to fill in the gap that sometimes exists between the theoretical developments and the real applications.
Mobility is a key element within the network, and that's why we have been collaborating with different scientists from top universities in Europe.
Within the Tempo project, I think I've really improved my technical skills. And in addition, I think that thanks to the international environment in which this kind of project is taking place, really helps you to improve some other kind of soft skills like language skills and communication. Apart from the technical development, this kind of projects really help you to build a large network all around Europe and helps you to develop a deep relationship with your other colleagues and the supervisors that are part of the project, and I'm sure this relationship will go beyond the end of the project.
I'm Giovanni Licitra, I'm Italian and I'm a PhD fellow at Ampix Power, Netherlands, and University of Freiburg, which is in Germany. During my PhD work, I've been working on how to generate optimal flight trajectory for the aircraft, how to identify it via flight test experiment, and ultimately how to design a reliable feedback control law in order to improve the efficiency of the so-called second generation of wind turbine. Tempo allowed me to work on a very interesting international environment, but also improve my communication skills, as well as attend many workshops on optimization, business related, as well as how to make a pitch and so on. So at the end we got a full package of knowledge. The concept of Tempo is also think out of the box, because in this case I've been working on a startup, which means get your hands dirty and grow fast and really learn. An airborne wind energy system has lots of advantages, which is produce the same amount of power of a wind turbine but with less material cost. But you can imagine that such a system is quite complex. So my goal was provide a meaningful research for model this system, how to compute trajectory, how to describe and design a control algorithm, hoping that one day this system we can see and fly inshore and offshore, but ultimately providing a greener environment.